Grasshoppers are among the most intriguing creatures in the animal kingdom, displaying a combination of simplicity and complexity that allows them to thrive in a variety of environments. One of the most remarkable features of grasshoppers is their auditory system, which, rather than being located in the head as in many other animals, is instead found in a much more unusual location, the abdomen. This specialized anatomical adaptation serves a critical role in their survival, communication, and reproduction, providing an example of how nature can evolve remarkably effective solutions to environmental challenges. The grasshopper's auditory organs, located on the first abdominal segment of the thorax, are called tympanal organs. These organs are simple, yet highly efficient, serving as a sophisticated sensory system that allows grasshoppers to detect and respond to sound waves. Unlike human ears, which are external and complex, the grasshopper's ears consist of a pair of small, circular openings located on either side of the insect's body. These openings lead to thin, flexible membranes that vibrate when sound waves strike them, creating vibrations that are transmitted through the body to specialized sensory cells. These sensory cells, or mechanoreceptors, detect the vibrations and send electrical signals to the grasshopper's central nervous system, where the sound is processed and interpreted. The location of these auditory organs on the abdomen is highly advantageous for several reasons. First, placing the ears on the abdomen rather than the head means that grasshoppers are able to detect vibrations from a wide range of sources. Sounds in nature often travel through the ground or air, and the abdomen is better positioned to sense these vibrations in a more 360-degree pattern. This allows grasshoppers to pick up on sounds coming from different directions, whether it be the rustling of leaves caused by a predator or the calls of potential mates. This heightened sensitivity to sound direction is vital for their survival, as it enables them to detect predators, such as birds, approaching from any angle, giving them more time to take evasive action. Moreover, the abdominal placement of the ears minimizes interference from other environmental noises, such as wind or rain, which might drown out the sounds that are crucial for the grasshopper's survival. Grasshoppers are particularly sensitive to low-frequency sounds, which are commonly produced by predators like birds. Their tympanal organs allow them to hear these subtle, low-frequency vibrations from a distance, giving them the ability to detect predators early and escape danger more effectively. In this way, the abdominal ears are not only a means of communication but also a sophisticated survival tool, in addition to detecting the presence of predators. The grasshopper's auditory system plays a crucial role in their mating behavior. Male grasshoppers produce a wide range of sounds to attract females, primarily through a process known as stridulation. This is where the male rubs his hind legs against his wings, creating a characteristic chirping or buzzing sound. The frequency and rhythm of this sound can vary significantly between species, and females are highly attuned to these nuances, using them to assess the quality and suitability of a potential mate. The tympanal organs in the abdomen are finely tuned to pick up on these mating calls, ensuring that males and females can communicate over long distances. Interestingly, the ability to detect these calls is not limited to males and females of the same species. Grasshoppers can also use their ears to listen for the sounds of competing males, which can help them avoid unnecessary conflicts or adjust their behavior in response to competition. This auditory sensitivity gives grasshoppers an advantage in both attracting mates and defending their territory, as it allows them to listen and react to environmental sounds in a way that many other animals cannot. The abdominal ears are not simply passive receivers of sound, however. They are highly adaptive organs that actively filter out irrelevant or background noise. This is an important feature, as grasshoppers are often surrounded by environmental sounds that could potentially mask more important signals. For example, the noise of wind rustling through leaves, the hum of nearby insects, or the distant sound of rainfall could easily interfere with the grasshopper's ability to detect a predator or a mate. The tympanal organs allow the grasshopper to focus on the specific frequencies that are relevant to its survival or reproductive success, while filtering out unwanted noise. This filtering mechanism allows grasshoppers to remain focused and responsive to the sounds that matter most in their immediate environment. The ability to hear and respond to sound is crucial for grasshoppers in both their social interactions and their survival strategies. By detecting the sounds of potential mates or rivals, grasshoppers can adjust their behavior accordingly. For example, males may adjust the pitch or rhythm of their calls in response to competing males, or they may increase the volume of their stridulation to attract females from a greater distance. Similarly, if a grasshopper hears the distinctive sounds of an approaching predator, it can take immediate action to flee, jump, or hide, depending on the situation. The abdominal ears thus provide grasshoppers with the auditory information they need to navigate their world, making them better equipped to survive and reproduce in their environment. From an evolutionary perspective, the grasshopper's abdominal ears provide a fascinating example of how natural selection can lead to the development of highly specialized organs. Over millions of years, grasshoppers have evolved this unique auditory system as a response to the specific demands of their environment. The location of their ears on the abdomen is a clear example of how evolution can take advantage of the available anatomical space to create a highly efficient sensory system. This adaptation allows grasshoppers to detect sounds that are crucial for their survival and reproduction, while minimizing interference from the surrounding environment. As scientists continue to study the anatomy and behavior of grasshoppers, the role of their abdominal ears offers valuable insights into the diversity of sensory adaptations in the animal kingdom. The development of such a unique auditory system highlights the versatility and ingenuity of nature in crafting solutions that optimize survival in a wide range of ecological niches. Whether through the detection of predators, the communication of mating calls, or the ability to filter out irrelevant sounds, the grasshopper's ears serve as a testament to the remarkable power of evolutionary adaptation. In this way, the study of grasshopper anatomy and behavior provides a window into the complexity of life on Earth, revealing the many different ways in which animals have evolved to thrive in their specific environments.